I'm on mute. Always test the audio. Yep, so we're good. What is up, everybody? Happy Monday. We are live from the Alpha Esports and Technology Center. Uh, it's Monday. It's definitely a better start to the week than last Monday. Um, if you were here last week, we kind of talked about how had a situation where there was an accident in front of the house and it caused a whole bunch of issues, including the loss of power and everything. And it was just a rough start to the week. But we're here, a little tired, but happy to be here. Hope everybody's Monday has been going well. Let me know if y'all watched the Super Bowl last night and what you thought about it. I'm actually glad that the Eagles won, even though I am a Giants fan. I am glad that Jalen Hurts won. I'm actually really happy for Saquon Barkley. I feel like I feel like the Giants did him extremely wrong, and um, causing causing it. Hold on one second. Yeah, I feel like how the Giants did him was extremely wrong, and I'm glad he went somewhere where he could be appreciated and his talents recognized and used to the best of their abilities. And he definitely did that. Um, you know, he didn't have a great Super Bowl per se, but he definitely killed it all. All throughout the playoffs. So I mean, I expected Kansas City to probably have an answer for the run game. That was pretty much all they had an answer to since they weren't able to get things running too much on offense. Um, but again, I'm not complaining. Yeah. And so, like I said, the Super Bowl was awesome. Like I said, we kind of just laid low again with the family, just hung out, um, made some food, had some nachos and some snacks. And, it was just me, my wife, and the kids, and the dog, and the bearded dragon. Um, so definitely had a quiet but fun time. And then, like I said, got up today and got started working on some new articles at Technology Advice, the day job. And then now I'm over here, opened up Alpha Esports and Technology today, and had a couple calls, had a couple sessions, and now we're going to get started. So with that, if you remember the stream from last, was it Thursday? I think it was last Thursday. We talked about future plans, and one of the future plans during that Q&A session was AppSec Rabbit Hole. And I said I wanted to get it started, and that's exactly what we're going to do. So my idea for AppSec Rabbit Hole today is we're just going to kind of cover the basics of what app what I don't even think we're gonna get into that. We're gonna probably get into just the basics of cybersecurity and Linux. So we're gonna do a little bit of stuff on Try Hack Me, and then after that, if we have some time, we'll probably restart our day one of Minecraft because Lord knows last week was horrible. It was fun if for some people who were watching, but for me it was horrible. We were supposed to kind of get things situated, and that didn't work. And then I ended up getting I died, came back, started it up again, got attacked by a polar bear, and then I spent my first night in a sauna or some. I think it was a sauna. I don't remember. It was like an outhouse or something, but it definitely wasn't what I envisioned for my first day of Minecraft survival. So let me know in the comments. Let me know in the chat how your week's going. If you got any questions for me, if you're excited for the week, what you liked about the Super Bowl, and then yeah, we'll just chop it up from there. I just need to finish up trying to schedule up. schedule a post for Tech Term Tuesday. Let's see. Causing it to. I can't remember. I'm struggling to spell today. Temporarily. Pause. Or. Causing it to. I can't think. Like I'm drawing. All right. Causing. Traders are overwhelming it with traffic and causing it to. Sorry, y'all. Give me one more second. They know that they're upstairs. They know they have to take him down, but he's just not giving up. He's having an incredible game. And I see the support as well. He's inside the connector, watching and waiting. How does it go? He doesn't want to give blood. He's also here. They've just walked into a line track. Okay. Oh, sorry, y'all. Give me 1 second. Let me take this call. Wow. That's crazy. You know, I don't know what people believe in or if people believe in things, but sometimes things happen and you can only it can only be a higher power. Like you know how you just like you go through certain things and you feel like, man, if I'm doing this or if I'm doing the right thing, give me a sign, let me know, like, or even if you just have a quiet moment, you're like, man, you know what, I made a mistake, or maybe this isn't up to me, or maybe I should give up or whatever. And then you get a phone call or an email or a text message or something that helps you or gives you the sign that you need to keep going. That was one of those calls, so that was cool. It was someone that I worked with in the past, and I guess something that I said during one of my presentations resonated with them, and they just wanted to kind of let me know that and try to figure out ways to help grow what we're doing. So that's awesome. That's awesome, because I'm not gonna lie to y'all. There are times or there are days where it's like, I don't know. I don't know if I can. I don't know if I should. I don't know if I can get up and do this today. So it's really cool to get those calls or those emails, or and again, you're not doing anything but being your genuine self. You know what I'm saying? Like you're being you. You're not doing anything outside of the ordinary. You're not pretending to be something you're not. You're not, telling no BS. You're just doing what you feel is right and being the change that you want to see. And sometimes doing that isn't the easiest thing in the world. So to get the recognition and to get the flowers sometimes means a lot. All right. So I'm not gonna get overly emotional about it. But we're going to jump into a couple things, and I guess I'm going to be giving the good folks over at Try Hack Me some free promotion, but that's okay because you know what? I think it's a really cool platform, and it does a lot to kind of give people that gamified, hands-on experience to learn the ins and outs of cybersecurity. So what we're going to do is we are going to start from. Are we starting from the beginning? I don't think we're starting from the beginning, right? No, I don't think we're doing that. Actually, you know what? No, we're not. We're gonna let's start in section 2, right? So we're gonna assume that if you're here listening to stuff about web and application security, that you already know about the basics of cybersecurity, and you don't really need to do all of that. Where are we? Oh, this is the OSI model. So I want to actually back up. So the path that we're going to look at is we're going to jump around a bit. So we'll probably do this we'll finish up this pre-security. We'll go into that, and then we'll go into some Linux because we're going to be picking. We're going to be picking parts of this. I don't think we're going to follow the whole path. We're definitely going to check out the web fundamentals and the web application pen testing because that falls into the stuff that we're working on for the rabbit hole. We'll probably what's in the security engineer path. Governance, regulation, threat modeling, risk management, vulnerability management. You know, we might. Let's see. Oh, I definitely over here when we get into the OWASP top 10 and then the API security and then the secure software development lifecycle, SaaS, DaaS. So we will probably touch on different parts. Let's see, DevSecOps again. We're definitely gonna we'll definitely touch the DevSecOps. This attacking and defending AWS, that's an add-on. I don't think we'll do that. So yeah, I think that's where we're gonna go with it, y'all. So again, so we have the pre-security path. The pre-security path kind of just goes over the fundamentals of the networking, how the web works, Linux and Windows. So we're gonna try to knock out a bunch of these today. So I know I've done some of them. I'm gonna see if we can. I think we're able to clear it. Whatever. It's okay. So we're gonna start with again. What is networking?
Hey everyone, welcome back to another video here on
a 23-minute video. Like I said, we're going to be kind of just brushing through this. So I'm going to go ahead and put the link in here to what rooms we're looking at. So if you want to follow along, you are more than welcome to. Try Hack Me is free. Most of it is free. They do have a paid version. I would recommend getting the paid version if you choose to. If not, or you just want to kind of check it out first, that is also fine. Let me come back here. That's also fine. But if you do want to get the paid version, I will ask. Again, you don't have to. It's not mandatory. However, it would be greatly appreciated if you were to use our link to get a subscription. I said we get, we don't get much from it, but we do get something. I'll see if I put the link in here in a little bit. Man, I don't know. I'm sorry. I'm still kind of bugged off of the. So, all right, I'm gonna just give y'all. just give y'all a quick, rundown. So, as you know, I do have multiple other jobs, wear multiple other hats, while we're building out our program here at Alpha Esports and Technology. And we have been blessed to come across so many people who have been willing to help, um, put us in contact with other people who would be willing to help, um, offer advice, whatever. And I'm not going to lie, I've probably dropped the ball a little more than I would have liked to. Reason being is because it's, for the most part, it's me. Um, I do have like interns and other people and some family who help from time to time. But when you're working full time and then coming in here, working a business, and then um, you know, trying to stay active and everything else. Sometimes things fall to the wayside, and so I'm not blaming anything or anybody. It's just, you know, I've probably could do a little better now. I mean, that being said, there are also other things that I feel are that are challenging. I actually touched on that in the Q&A in the last live stream. But that being said, um, I don't know everything there is to know about. I don't know everything there is to know about running a business. I definitely um, get overwhelmed. Definitely overwhelmed when, like I said, having to essentially work 3-4 jobs. So it it gets difficult when you try to make that work, and like I said, your original plan doesn't work, and your plan B, plan C, plan D, that those things don't work, and you start to get a little discouraged. You start to question yourself. You start to feel like, is it me? You know, you look at other people who might be doing something similar, and even though you don't know what they brought it to the table or what resources or connections they had prior to, it's hard not to look at the next, someone else, and then maybe in the same area, same state, same, geographic location, same coast, whatever, and look at it and go, damn, what are they doing that I'm not? Why are they all so much more successful than, you start getting in your own head. Um, so yeah, it does get to be a bit much. So again, to get that recognition from time to time is pretty cool. All right, so networking basically are just things that are connected, right? So in the term for technology, networking is everything from your router to your devices. If you're on wireless or Wi-Fi, that's a Wi-Fi network. So your phones that are connected to your Wi-Fi, or wherever you're watching this is connection. People, so you can have a personal network or a business network, right? So your group of friends, your group of family, your coworkers, those are all networks. So networks are just things that are connected. um so like we talked about, so in technology, it's just everything that is technology related that are connected. So your devices, so your phones, your computers, your we're talking, we're in the age of IoT, so your smart watches, and everybody saw the smart glasses and stuff that Meta's putting out. So those are all going to be things that are connected via a network. So um, these, like I said, so networks are just integrated in your everyday life. That's what it says here. And then here's the thing below. So most of the times you'll see Alice and Bob. That whenever talking about network, there's always going to be like Alice and Bob. There might be other people, but you'll usually see Alice and Bob. So Alice, Bob, and Jim have their own network, right? So it's a network that they have where they're sending messages back and forth to each other. So this is essentially like when you send an email and you CC other people, right? That's all those, now all those people are connected, right? You set up a group chat, all those people are connected. So those are networks, okay? The internet is essentially just one giant network. Okay, so the internet consists of multiple devices, multiple networks, right? So it's so many networks within itself. That's the internet, right? So let's think of, I don't know, let's think of your service provider, right? You might have Spectrum, or you might have Optimum, or I don't even know what it is, Altice or something now. I don't know. You might have AT&T. You might have Google Fiber. If you are, you're lucky. You might have Verizon, right? You might have T-Mobile, whatever the case, whatever internet you have, right? But let's say your whole block has it, right? So your whole block has AT&T. Your whole block has Verizon or whatever. That's your service provider, but that's your internet, right? So that's your internet, and then every house that is connected to that network, that internet network, is a smaller network. So that's essentially what it is. You have your internet, and then you have all. Then your internet is a network that consists of smaller networks. Okay, so that's essentially what the internet is, without getting into all the bells and whistles. All right, so now using that same Bob and Jim, now you have Alice, Bob, Jim, Toby, and Zane, right? Now, as you can see here, Alice is connected to everybody, right? So Alice would be the internet service provider in this case. And then Toby connects to Alice, Zane connects to Alice, Bob connects to Alice, Jim connects to Alice. So these are all the smaller networks, right? But then you have Jim and Bob who are also connected, and they're connected through Alice. Same thing here. If Zane and Toby were connected, then they would have their own network connection. If Toby and Jim were to connect, they would have their own connect network. You see what I'm saying? So Alice can talk to all of them, right? So Alice is the internet. Okay. Then it kind of goes into the history of the internet, which was the ARPANET, which was in the like 1960s, and it was funded by the United States, right? It was a project by the United States, um, and then it wasn't until like the late 80s where you started to see the internet as we know it today. So that's where you see the www for World Wide Web. Um, but like I said, at that point, the internet was just used by the government, and then it became somewhat public. But it was just, and then it says the internet started to be used as a repository for storing and sharing information. So again, remember what I was saying? The internet is the main source, and then you have the internet consists of smaller networks everywhere. So here you have your internet service provider. So again, this would be your Verizon, your T-Mobile, your Google, your Spectrum, AT&T, whatever. And then it connects to these devices here. So whenever you see these devices on a diagram, these are going to be your routers, right? So when you get your routers at home, when your internet, when you get internet in your house and they come in with the modem and the router, that's what you'll see here, right? So the internet connects to the router, and then from the router you connect to all your devices. Same thing here. Internet connects to the router connects to these devices, and these are on the LAN, so these are connected via a wire. And then this one, you see the internet connects to the router, but then the router is connected to a printer via a cable. But then you see here is connected to what looks like a mobile device and a laptop, so that's wireless. So that's a Wi-Fi router. And you can also see that too because you got the two little small antennas on the side of the router. Okay. Internet. So the internet consists of a private network and a public network. Um, did they touch on that? So okay, so the public network would be your public internet IP address, right? So that's actually, let's use this as an example. Let's say you go to, I don't know, McDonald's. I don't go to McDonald's, but let's say you go to McDonald's or Starbucks or something like that. You go to Barnes and Noble and you connect to their public internet, right? You come to Alpha Esports and Technology. You ask, hey, what's the Wi-Fi password? Right? That's the public Wi-Fi, right? But then my PCs and all my internal devices, they're connected to what is known as the private network. So, or in internet terms, you have your public internet address, which if you Google your IP address, you'll see your IP address is probably a lot different from what you would see your IP address would be in your house, right? That's because that's your public IP address. That's your IP address on the outside. But then internally, you have your private IP address, and that's where you get your 192.168.1 dot whatever or 10 dot whatever, right? Those are your public networks. Okay, so now it tells you how do you identify devices on your network. So in order to do that, you have what is known as the IP address. So remember, I was just saying your private IP address would be like a 192.168. That's your IP address. So you think of your IP address as your calling card for your device or your connection. Okay. Your device usually has your IP address, which is the address that's given to it to connect to the internet. And then you have the media access control address or the MAC address. That's like the serial number of your device, right? So my phone, right? So my phone, which is little, the screen's a little whatever. So my phone has an IP address that it was assigned when it connected to the Wi-Fi here in the center. But the phone itself has an internal MAC address, which is essentially the code that will let my router know or my network know that this is indeed a phone. Okay. So IP address, IP stands for Internet Protocol, and again, that's a way of identifying the host on the network, and it can be associated with another device without the IP address changing. I'll explain that in a second. Okay, so the IP address is usually split into four octets, not octets. Okay, and then the value of each octet will basically summarize the IP address of the device on the network. All right, so that goes through a process known as IP addressing and subnetting. Let's see. What's important to understand here is the IP address can change from device to device, but cannot be active simultaneously more than once on the same network. So yes, you're given an IP address on the network. No one else can have that IP address while you hold that IP address. Okay, so that's like you get on the network, and it's like, okay, cool. You have been granted a ticket. You are user number one. Right? And as long as you are user number one during that session, no one else will be user number one. So if someone else comes in and says, hey, I want to be user number one, they're going to be like, oh, sorry, you can't. Someone's already been assigned that number. Someone's already been assigned that ticket. Now, when you disconnect, you'll be then it kind of frees it up. Okay, so that's essentially what they're saying there. Okay, IP addresses follow a set of standards known as protocols. These protocols are the backbone of networking and may force many devices to communicate in the same language, which is something that we'll come to at another time. However, we should recall that devices can be both on a private and public network. Depending on where they are, will determine what type of IP address they are given, a public or a private IP address. Okay, so public IP address is used to identify the device on the internet, whereas the private IP address is used to identify the device amongst other devices. So Remember what I was saying about before, if you were to Google your location or Google your IP address, you would get your public IP address. Right. So here's a perfect example. You have a device named of desktop KJE. What we're just going to call it desktop KJ. So internally, desktop KJ has an IP address of 192.168.1.77. That's their private IP address. So that's the IP address that they were given on that internal network to identify where it is on the network. However, if you were to look up the IP address for desktop KJ on the public internet, which is basically from the internet service provider's position, you'll get a different IP address, right? So let's see. I wonder if there is a diagram. There is no diagram. So we're gonna see if we can diagram this real quick. I wish I had I'll just use Canva. All right, so we will share this tab. All right, so here we have Canva, right? Can I just write? I've never used the whiteboard on Canva before. Yeah, draw. Okay, so cool. So we're gonna try to draw a cloud here. With a pretty little cloud. Right? And then we'll go ISP. So ISP is your internet service provider. Okay, so this could be Google or AT&T, right? So that's your internet service provider. So that is outside, right? And now we're gonna draw a pretty little house. Oh boy. All right. Okay. Whatever. The house is okay. Throw some windows and a door. Okay. So you have your house, and let's say we're gonna just do this. That's your router. Ugh. Okay, no, that was horrible. Where's my eraser? Okay, so whatever. This is your router. Okay. So your ISP might give you an IP address of, let's just use the example that was given here, 86.157.52.21. So 86.157.52.21, right? So come back over here. So 86.157.52.21. 52.21. What's going on, Ty? So that is the IP address that is given to you by your internet service provider, and that is your public IP. Okay. All right. So you have your public IP address here. Now, so this is your internet service provider. So this is your cloud, right? And now from your cloud, you call the cable guy. So cable guy or internet service provider guy. And his job is to connect you from here to here. So he creates that connection. And we're just going to go around the public IP address. Right? And now he's going to bring it through there into the house. So now you connect into the house, and now you connect to the router. So now this is your oh jeez. Man, waiting to get off work to hit the gym. Man, I need to regulate my life so I can get back to the gym, man. Seriously. All right, so I'm just gonna because I can't write small. So I'm gonna say private IP. This is horrible. Um, we're gonna invest. If this takes off, we're gonna invest in like a whiteboard. Okay, so you're given a private IP, and let's say the private IP. What did Try Hack Me say? 1.77. So we're gonna go 192.168.1.77. Okay, so now that is what you're given when you connect there. So now we're just gonna so right, boom. So that's your private IP. So that was scary. So you have your public IP address that's given to you by your internet service provider, and then you have your private IP that's given to you from from your device. So this could be your router or your switch or whatever, right? So actually, we're actually going to fix something real quick because you're not going to get 192.168.1.177. You're when you connect to the router, you're going to get 192.168.1. I don't know, it could be 1 or maybe even 100, right? But for the sake of this, since this is 77, right? All right, so now you have that. Now, let's say you have, I don't know, let's say you have an attic, and or actually no, we'll draw a basement, right? Because hackers stay in their basements, right? That's the stereotype, right? So now we'll call this. But yeah, Ty, I need to get back to the gym for real, or get back on some routine. Like I actually started making the process. I'm not gonna lie, money's tight, and I ain't got money for a gym membership at the moment. But I actually rebuilt my heavy bag setup and all of that. So I got my bike, I got my heavy bag. So I'm gonna start with that, and then hopefully as things get a little bit better, we'll do that. All right, so you have your house, and then you have your basement, right? In your basement, you have your TV that connects to the internet. You have you gotta have like your video game console, right? So you gotta have call this like this is your Xbox here. You have your computer over here, right? Right. Um, I don't know. Let's see what else you have. Um, I don't know. You have something else. You have another TV, right? So your router, whether it's via LAN or WAN, so whether it's connected from an internet line or Wi-Fi. Hey, what's going on, Armored Crab? Appreciate it. 10 minutes on a heavy bag is a good start. Like I said, I'm definitely trying to. Like I said, life is I don't know if you caught what I was saying earlier, but like I said, life is definitely life, and it's 2025, and I'm already like, man, this is crazy. All right, so again, we have our basement. So I'm just gonna erase it from saying basement now, since we've already. Geez, I didn't want to erase everything. Oh, whatever. So since we've established that this was the basement, excuse me. Um, but real quick, what I've been doing is like, so I try to dedicate like 30, 45 minutes on the bike, and then I try to dedicate another like I try to do like 9, 10 rounds on the heavy bag whenever I can. All right, so again, so this is the basement, right? So we'll just put B for basement over here. So now you have your public IP address, again, just a recap, that gives you the 86 157 52/21. Then you contacted the cable guy or the internet guy, and he said, okay, I'm going to connect you here, right? He works for this company out here. Now he's going to get you internet. He comes into your house. Let's just draw a little happy little door. He walks in and he connects a router that's connected to the ISP. Then when you connect to that and you turn it on and everything is connected, you have a private IP address of 192.168.1.1. That's your router. Oh, no problem, man. No problem. Thank you. I appreciate it. I appreciate the follow, man. If this, I appreciate it. As long as, do what you got to do. Got to get that GTA in before GTA 6. All right. So he connects to the router. Router is given an IP address of 192.168.1.1. So now you connect all of your devices to this router. So we're going to go connection here. We're going to go connection here. And we're going to go connection here. And we're going to go connection here. Okay. So everything in this network is going to have the same 192.168.1. So we're not going to go ahead and write out the whole thing because it's going to get really messy. But what we'll say is now connected to the basement, you have 1, 2, 3, 4 devices. So now this device might be given an IP address of 10. This IP address might be given an IP address of 20. And then this IP address is given an IP address of 77. And then this one is given an IP address of 74. Right? So now you have your private IP address, 192.168.1.1, and then it connects down here. Now you're given 192.168.1.10, 192.168.1.20, 192.168.1.77, 192.168.1.74. Okay, so these are your private IP addresses. All right, so this is your private IP range. Okay, so just to recap, your public IP address is from your internet service provider. You're given a public IP address like 86, 157, 5221. If you were trying to locate your IP address externally, you'll get something like this, right? I'm not going to do it just because there are security implications. When you kind of put your public IP address out there, and I don't necessarily want to do that right now. But if you were to Google what's my IP, right? So if you Google what's my IP, you should get some crazy IP address, right? You can go to like what'smyIP.com, what'smyip.com. NordVPN actually has a thing where you can check there as a part of their package, and you can you can get your IP address, right? But then if you were to then do something like this, let me share the right thing. But if you were to look at this now, you could see I have a different IP address, right? So if you were to go in your command line and type in ipconfig, or if you're on Linux, ifconfig, or IP, I think it's IPA, you'll get a different one. So like here, my IP address is for one of my Ethernet ports is 192.168.56.1, or my other network with 10.1.10.248, right? So those are my private IP addresses. Let's come back over here. Right? Those were my private IP addresses, right? And you'll have a similar IP address if you were to do that for yourself. If you were to do IP config on your computer, on your command prompt, you would get the same. However, if you were to do what's my IP or go to what'smyip.com or nordvpn.com or anything like that, you'll get your public IP address. All right. So we're just going to go ahead and delete all of that. What's going on, Thumbstick? I was explaining IP addresses, and then I was trying to use this whiteboard thing, but I'm doing it from the mouse. So, but yeah, I can imagine. Yeah, I can bet it would look a little confusing. All right, so that's basically what's being explained here. Your different devices. So you see, desktop KJ has a public IP address of that, and then the internal IP address or the private IP address would be that. Okay. Hey, no problem. No problem. Glad you're here. So let's see. As more devices become connected, like I said, it's becoming harder to get public IP addresses. So if you notice when I did the IP config, there was also an IPv6 address, which looked like this here. That's because the internet is allegedly running out of IPv4 space or IP version 4 address space. So the 4 octets, as you see them, 192.168.1.77, 10.1.10.1, whatever the case may be, those are what is known as an IP version 4 address. IP version 6 supports up to over 340 trillion IP addresses, and basically resolving the issues that came with the version 4. I don't think so. When they made version 4, when they made IP addresses, I don't think they expected everyone to have that many devices connected to the internet. I think they still thought the internet was just going to be this small thing, and now here it is. People basically can't live without it. So MAC addresses. Are your Ty, I am in this one right here, the tryhackme.com. What is networking? So devices on a network will have a physical network interface, which is basically your motherboard. Your device, it's like a chip on your device's motherboard. So all technology has something that's known as a motherboard or like a main board or a CPU, right? So when you hear people talk about computers, they're not necessarily talking about the computer. They're talking about the tower or the monitor, but the computer itself is actually a small chip. That's similar to what they have on the motherboards on all devices. So anyway, the microchip has like a network interface, and is given an address known as the media access control address. So that is hexadecimal 12 character that's split, as you see it here, between like here with the colon, right? And it's the two parts. It's separated as the first 3 sections here is the vendor, right? So if you had a device that was built by Samsung, the first 3 parts of the MAC address would identify that it's associated with a Samsung. And then after that, you have your unique address, right? So that's like, think of it as parents and children, right? If my last name was Smith, my kid's last name would be Smith, right? So we're just kind of flipping the MAC address situation backwards, right? So so the unique identifier for my kids would be their first name, right? So it would be Bob Smith or Alice Smith, since we're going to keep up with the Bob and Alice lingo. So Alice Smith and Bob Smith, right? So the unique identifier would be their first name, but the vendor who built the network, who built it, where they came from, is Smith, right? So Alice is the unique identifier. Smith is the vendor or the creator. Okay. Um, now they kind of going from a cybersecurity standpoint of MAC addresses can be spoofed. They can. It's known as spoofing. This is where you can actually fake the MAC address of the device. So if I wanted, let's say I was working on something that had some type of access control, I could manipulate the MAC address to say it's coming from a Samsung device, right? So, but more on that later. Okay. So then they talk about places like cafes, coffee shops, hotels often use MAC address controls when they're using their guests and public Wi-Fi. The configuration could offer better services like faster connections for a price if you're willing to pay the fee. So again, that's how they use it on a publicly, right? They could say, okay, if you want premium access, they would then get your MAC address and then add your MAC address to their access control list to say give them premium access, right? That's like a VIP list, right? So again, um, Alice and Bob want to enter the club. Alice has VIP access. Bob doesn't. Sorry, Bob. Alice goes through there and says, yes, that's exactly what Mac Changer is, Ty. Mac Changer is the tool in Cali that's used to change the MAC address. So like I said, so Alice goes in there and was like, hey, I'm trying to get to the booth, and, whatever. Like, hold on, let me check. Yep, Alice Smith. Yep, you are here. Okay. Bob says, hey, I'm trying to get into the VIP section. They go, nope, you're not on the list, and you got to pay extra to get on the list. So that's basically what Mac control list or Mac access control are. Okay. All right. So ping. So ping is basically if you've done anything in tech, you've probably pinged an IP address or pinged a website before. So ping uses a protocol. Well, for one, yeah, ping basically, like I said, is a network tool that's going to test the connection, right, to see if you're connected to another device, if you're connected to the internet, if you can connect to the website, right. And ping uses what is known as ICMP, or the internet control message protocol. Okay, so what it does is it sends out packets to determine the connection and the strength of the connection between the device, right. So I'll just bring up this again. CMD. Boop, 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 boop. All right. So you have your IP address. So if I wanted to ping 10.1.10.141, as you can see, I'm getting a response that says the device is unreachable. And the reason why the destination is unreachable is because that server that I'm trying to ping is not connected, right? But let's say I did ping, if I said ping 142, actually, I'll take that back because that one is also unreachable because I just looked over at it and that server is also unreachable, right? So let's go. So if I said IP config, and let's say my IP address here is 10.1.10.248, let's try 10.1.10. Did I lose y'all? I think I did. I don't know what happened. Bring it back. Bring it back. Bring it back. Weird. All right. Well, sorry. 10.1.10. Well, I guess my device. I guess it didn't. It doesn't want to share my screen anymore. Don't know why. But if you were to ping a live host, what's going on? What's going on, C Smith? Yeah. So if you were to ping a live host, you would get the response back that you could see here. Yeah, I'm not sure what just happened. I was sharing my screen and then it stopped and whatever. So let's go back to here. So since I couldn't do it on the live, I couldn't do the live demo. We'll just use their example. So pings can be performed against devices on a network, such as your home network or resources like websites. And then it would say ping IP address or website URL. So in the example, they pinged 192.168.1.254. And then as you see here, they got the response back that said they responded back within 2 milliseconds, 2.5 milliseconds, 3 milliseconds, 10 milliseconds, and four almost 4.5 milliseconds. So it came back, and then when it broke it all down, it averaged out to almost 4.2 milliseconds. All right. Now, if you're going to do the same thing, ping the IP address of 8.8.8.8. Pinging the correct IP address will reveal a flag to answer the question below. So we'll just do this real quick. So right now is using ping.c4. So basically what's happening here, this is a Linux machine. So it's saying run the ping command, but we only want you to do it 4 times. So that's what the -C flag stands for. The -C stands for count. So ping this 4 times, and we're going to type in 8.8.8.8 since I think that's what they said to do it. Right. And as you see, it comes back, and then it kind of gave us the flag here. So again, we already have that in here, so it's not going to let me do it again. But that is essentially how you ping, and that is what ping does, right? So y'all want me to do another diagram? Let's see. Let's try this here. Okay. So again, we're just going to kind of quickly go through what happens with ping. We'll have device 1 and device 2, right? So this is a computer. So we got to draw a little monitor and keyboard. And then this is a server, right? So we'll just call it a server. Okay. Right. Ping. Right. So now you want to run a ping. So basically what's happening when you're sending ping, you sent the ping command to that IP address. So now it's going to check if there's a connection. And if there's a connection because it's on, it's going to come back and say, yeah, yes, I'm here, right? So a ping goes out and says, hey, IP address 10.1.10.141, since that was the server that we tried, but the server is off. It would say, hey, are you on, right? So to avoid, let's say, we're going to say, are you on? Right? And because it is on, it's basically going to come back and say, yes. And that's where you get that's where you get these responses. 64 bytes from 8.8.8 ICMP, right? So it's telling you it did receive data from the IP address you requested. It used the ICMP, so it used the Internet Control Message Protocol, with a time to live of 56, and it responded in the 8.47 milliseconds. Right, so that's what's happening. You're basically asking it, "Hey, are you on?" And it says yes, and it does that. So that is how essentially ping works. Now, if it was off, you'll get the message that you got from earlier, where it said destination host unavailable. All right, so let's see. Let's see. I'm trying to double check all of my chat areas. And shout out, like I said, shout out to everybody where we are streaming. Let me know where you're watching this from. I see some folks are on. I saw one. I think two are on Twitch. Yep. So two are on. Actually, I have three on Twitch, and then three on YouTube. And then let me know if you're watching from LinkedIn, because I can't see the LinkedIn stream stats. So yes. So okay. So we covered all of that. Web certificates, man. Listen, I do web certificates is a little bit more. It involves a little bit more, but basically, web certificates. Think of web certificates as a um, web certificates are basically like an object and is used to verify the identity, as well as encrypt any data between the browser and the server. I think I have that right. So basically, think of web certificates like a ticket to secure your connection between on the internet, right? So um, you're given the certificate by what is known as a certificate authority. Okay, so we're gonna see if we can whiteboard this again, right? So your CA or certificate authority, they're the one. The CA is usually the one that's responsible for handing out the web certificates. So the CA has like basically is the most trusted thing on your network. Okay, and then from there, the CA will designate will sign trusted certificates. So it'll say, for example, um, Ty has access. This certificate grants Ty access to this resource, right from this browser to access this resource. And when you're transmitting data back and forth, so this could be logging in, or let's say you go on a website to pay, or whatever the case may be, that is going to validate that. It's going to, when you make that connection, is going to validate your web certificate to say, okay, you are who you say you are. You do have access, and we're going to allow you access with the encryption that was provided via the web certificate. Okay, so think of it as, like I said, think of it as a ticket. Think of it as a pass to access your resource, access to certain resources securely. I hope I broke. Like I said, I broke that down quickly. If you if you sign up for the cybersecurity cohort we have coming up, I will definitely go into that a little bit more in detail. But I just wanted to kind of quickly go over that. All right, so where are we at? All right, so we're done with this one. We're done with this one. Continue to learning intro to LAN. Continue by going to the intro to LAN room. So we'll just go ahead. So the intro to LAN room kind of goes over the different topologies. I don't think we really need to touch on too much of this with star and bus and ring topology. Um, I will okay. I will quickly go over a switch. What a switch is. So switches, it says here, switches are dedicated devices within a network that are designed to aggregate multiple other devices, such as computer printers and any other networking capable device using the Ethernet. These various devices plug into a switch's port. Switches are usually found in larger networks, such as businesses, schools, small size networks, or small size networks where there are many devices to connect to the internet. Switches can connect a large number of devices by having ports of 4, 8, 16, 24, 32, or 64 devices to plug into. Switches are much more efficient than their lesser counterpart like hubs and repeaters because switches keep track of what devices are connected to which port. This way, when they receive a packet, instead of repeating the packet to every port like a hub would do, it just sends it to the intended target, reducing traffic. All right, so and then it goes into a router. So the router's job is to connect networks and pass data between them. It does this by routing, hence the name router. Router is the label given to the process of data traveling across networks. Routing involves creating a path between networks so this data can successfully be delivered. Routing is useful when devices are connected by many paths, such as the example here. So I mean, this is a little crazy because you have one computer trying to from computer A to computer B, and you have looks like four routers in the way. But you'll probably see most of your networks probably look. Oh, I'm sorry, I'm in the wrong thing. Um, so what I was saying was we weren't going to really touch too much on the different topologies, but we were going to talk about LAN networks, right? So the LAN network. Um, is essentially just the local area network of everything that was connected. So in that house example that I used earlier, where the router connected to the basement devices, that essentially is a LAN network. Okay, the premise, and then it kind of goes into the topologies. I wasn't going to go into it, but you have your star topology where basically your network device is in the center. So this could usually be a switch or a hub. We just talked about what the switch is. A hub, think of a hub as a dummy device, right? So a switch route, not, a switch kind of um, directs traffic, right? So if you have think of a switch as a crossing guard or a traffic guard, right? They stand in the middle of the road and they're like, okay, you stop, but this one you can go this way, right? Or you stop, this one can go this way, or you stop and whatever, you go this way, right? That's what a switch essentially does. A switch looks at it and goes, okay, you're coming from where on the network and you're looking to access what, or you're looking to connect to who. Okay, you want to go this way. You want to connect to the printer. Okay, that means you go over this way. That's what the switch is going to do. A hub is just basically like everybody go where the everybody go where they're going. It's kind of repeating that information. Like, okay, you want to go here. All right, well, you're going to have to go through all of these to get there. Whereas a switch would say, okay, you're going this way. You're going here. You want to go straight here. A hub is just going to be like, I'm going to go here. I'm actually going to direct you here, 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 and here. And whatever one requested the information or whatever the one is you're looking for, when you get to it, you'll know because it'll make the connection. All right. So you have your star topology, right? So your star topology is everything is connected via this switch or hub in the center. Okay, so it's the most reliable, but like I said, again, how do I want to explain that? Actually, I'm just going to read it. Any information sent to the device in this topology is sent via the central device. So that's this, which connects. Then it says because more cabling and the purchase of dedicated network equipment is required, it's usually more expensive than other topologies. However, despite the added cost, this does provide some significant advantages. For example, the topology is more scalable in nature, which means it's easier to add more devices as demand continues. Right. So again, this might be similar to what you have at home. No, because there would still be a router involved. But the router would be in that central area as well. The bus topology. So your bus topology has basically one single connection, right? So this is your internet line right here. You have one single connection. And so remember what I was saying before about connecting, and it's like you're just going to go everywhere. That's what's happening here. So when anything is made, it's going to kind of go, and it's like, oops, sorry, not here. How about you? Oops, sorry, not here. How about you? Oops, sorry, not here. How about you? Oh, okay, yes, this is where I want to go. Okay. All the data destined for each device travels along the same cable. It's quickly prone to becoming slow and bottlenecked if devices within the topology are simultaneously requesting data. So again, but while you're doing that, someone over here is trying to send a request as well. Now that might cause collisions. Okay. The ring or token topology. Some similarities: devices such as computers are connected directly. I believe they use base 10. I believe so. I don't know. I'm a little rusty on on that. But ring topology works by sending across a loop until it reaches the destined server. So again, similar to this one, but it's just doing it in a ring. So if you're here and you want to send data here, then it's got to go past these first. So now when you talk about a switch, like I said, the switch is going to direct all of that. So here again, you have your internet connection, you have your router, and then let's say, and I'm sure we've all seen it. You connect your router, and your router probably has something like 2 or 4 ports. You're not connecting multiple devices, via an Ethernet cable that way. So you're going to connect the switch to your router that gives you added ports, right? So again, like for example, I have my router, and then on my router I have a 16 port switch because I think I upgraded it. I have a 16 or a 32, whatever. And then I from there I because I connect most of my stuff via the Ethernet. I don't have too many Wi-Fi connected things, except for like cell phones and stuff like that. And then I have a separate network for my like my IoT devices and all of that because I have trust issues. All right, so it is now 7 o'clock. We have been going now for about what, almost an hour and a half. Yep. So we're gonna go ahead and I'm gonna call it a wrap for that. But actually, let me see. Let's answer. Yeah, it's been 90 minutes. Like I said, I'm so it says bus does not directly use base 10. Instead, it refers to a network design where all devices are connected to a single cable acting as a bus and transmitted along the shared cable. The concept of the bus network doesn't inherently rely on base 10. An example, okay, so I mean, it can use base 10, but it's not, I guess it's not mandatory. I said, I don't know. It's been a long time since I really went into um, all of that. Okay, so hello, that is echoing. So, so yeah, so I think we are going to. Let me see. I mean, I got. Can I explain? Can we go? Can we cover subnetting in 15 minutes? Yeah, why not? All right, come on, let's do it. I wanted to do some Minecraft today, thumbstick. I wanted my revenge on the polar bears, but I think that's gonna wait because I guess I actually wanted to get here and start streaming earlier, but like I said, it's been a day. Like I said, it's not as bad as last Monday, but it's definitely been a day. So it says here we've previously blah blah blah. There's a certain amount of subnetting is a term given to splitting up networks. Yeah, it's better than last. Yeah, like I said, it's definitely better than last Monday, but it's still been a day. Like this week is gonna be it's gonna be interesting. Why are the repositories in Kali difficult to update? I was trying to install WebGoat via Docker and no dice. What repos are you trying to update? Man, you got me jumping ahead, but now I'm gonna be honest with you. I have not touched. I have not done a clean Kali install in almost a year now. Like summer would be a year since the last time because I I used it when I used it on the last pen test. No, I lie. I lie. I did a no June July. So I did a clean Kali install May or June, and then I taught a Kali class the end of June, early July. So I think that's the last. So yeah, so I haven't. It's been about 6 months since I've actually done a clean Kali install. But we'll be doing it soon because again we got to do that for what we're going to be working on. Um, we previously so subnetting is a term splitting up a network into smaller miniature networks within itself. Think of it as slicing up a cake for your friends. There's only a certain amount of cake to go around, but everybody wants a piece. Subnetting is you deciding who gets the slice and reserving such a slice is this metaphorical cake. So here you have three businesses or three departments. You have accounting, finance, and human resources. So again you have your main internet connection like we talked about before. So this is your AT&T, your Google, your T-Mobile, your Verizon, Spectrum, Altice, Optimum, whatever it's called. And then it's connecting to your router, and then from your router you're connecting to your switch, and now you have your accounting department, your human resources department, and your finance department. So it says, while you know where to send information in real life to the correct department, networks need to know as well. So network administrators use subnetting to categorize and assign specific parts of a network to reflect this. Best viewers and viewers online. Blah 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 blah. So okay, thank you. Sure, unwritten, recognized. Um, So subnetting is achieved by splitting up the number of hosts that can fit within the network, represented by a number called a subnet mask. Let's refer back to our diagram from the first room. So remember, we had the four octets: 192.168.1.1, and those are each octets, right? And each octet can go from 0 to 255. Okay, as we recall, an IP address is made up of four sections called octets. The same goes for a subnet mask, which is also represented as a number in 4 bytes, 32 bits, ranging from 0 to 255. Subnets use IP addresses in three different ways. It can identify the network address, it can identify the host address, and it can identify the default gateway. So now, if you split it up, you have the network address. So this address identifies the start of the actual network and is used to identify the network's existence, right? So, for example, IP address of 192.168.1.100 will be on a network that's identified by 192.168.1.0. So that is so the network address is the very beginning, right? And remember, in tech, um, 1 starts with 0. So what do I mean by that? 0 counts as the first number. So the network address will be the start of the IP range, right? Then the host address, this is the used to identify the device. So on the subnet. So for example, the device will have an address of 192.168.1.1, right? Or example, 192.168.1.100. Now, that's usually the first device on the network. So that's usually your router, right? So if you ever notice you had to troubleshoot your router and they go, hey, go to 192.168.1.1 or go to 10.1.10.1 or whatever it is. If it's usually that first number or 100 as the first number, and then you connect to um, that device. And then your default gateway is the address that's assigned to the device and is capable of sending other information to different networks. Okay, so any data that needs to go to a device that isn't on the same network, that's not on the same 192.168.1.0, will be sent to this device. These devices can use any host address, but usually use either the first or last host address, like 1 or 254. Okay. So in small networks such as at home, you will be on one subnet, and there's an unlikely chance that you need more than 254 devices connected. Okay. However, such as businesses and offices will have much more of these devices, like PCs, printers, cameras, and sensors. This is where subnetting takes place. Subnetting provides a range of benefits, including efficiency, security, and full control. So again, if you're able to allocate what goes where, it makes the network more efficient. Okay. Um, address. Okay. Now we go here. Recalling from our previous task that devices can have two identifiers: the MAC address, which we talked about before, and the IP address, right? Then you have the protocol known as the Address Resolution Protocol, or ARP, that's responsible for allowing the devices to identify themselves on a network. So when devices want to communicate, they'll send a broadcast to the entire network, and it uses that address resolution protocol to find the MAC address and the physical identifier of the communication. So remember when I did that ping before, where I was like, "Hey, are you here?" and it came back and said yes. That's similar to what happens with ARP. So ARP has the devices in a network that has a ledger to store information called a cache. So think of it as your, I almost showed my age and said Rolodex, but think of it as your contact list, right? So your contact list is your ledger that stores all the information of all the other devices. And it stores all the identifiers of all the devices. So remember, we said MAC address is split up into two parts. It's split up into the vendor section, the vendor information, and then the unique identifier, right? And then we flipped it and said Alice Smith. So Alice would be the unique identifier, and Smith would be the vendor information, right? So what would happen is you would go through your device and say, I need to find Alice Smith's device. And then it would go, oh, yeah, that's right. Smith, the vendor, and Alice is the unique identifier. Oh, that's this laptop, or that's this phone. And it would send that broadcast out to use to find the MAC address to identify the device. Okay, so in order to map these two identifiers together, the IP address and MAC address, ARP sends two types. It sends an ARP request and then an ARP reply. The ARP request is sent, the message is broadcasted on the network to other devices saying, what is the MAC address that owns this IP address, right? So again, 192, let's say 192.168.1.10, that's Alice's IP address. So it's going to say, hey, who owns 192.168.1.10? And then it's going to come back and say, oh, that is owned by Alice Smith, or Smith Alice, right? Because the vendor and then the unique name. And now it goes, okay, thank you, right? And if it's who it wants to connect to, then fine. But so what happened there was the request. So the request was like, yo, who owns 192.168.1.10? 192.168.1.10 said, oh, that's Alice. That was the reply, right? So you have your little gnat. So you have your request and then you have your reply. And then when you get the reply, you're like, yo, thanks. And you write that down. So 1.192.168.1.10, that's Alice's number, right? So that's essentially what happened here. Okay, and now they're just kind of giving you an example. So one, it says the source MAC address, and is asking the destination MAC address, and the message is who has IP address 192.168.1.10, right? So it's sending all the information, and then the looks like the switch or the hub says, "Me, I have that," and then it goes, "Oh, okay," and it sends it back, and now it's stored. So now for future references, because it has that cache, now like your phone, right? So with the first time you get somebody's phone number, you got to dial it in and probably call them to get them to store your number and make that connection. Then you got to type in the name or whatever name you got for them, whatever, right? But now the next time you go to make that call, you're just going to look for it and go boom, right? Or you might have it set to a speed dial where you just push a certain number, a certain button, and it automatically dials that number. Or you have voice dial that says, hey, call Alice, right? So it's because it's stored in memory. It's stored in the cache. So that's what's happening. So the very first time, yeah, it's going to take a little bit of work back and forth. But then after that, it's like, I got you stored. You're stored in my cache. You're stored in the memory. You're good to go. Okay. How much more time we got? All right, let's go through DHCP, and then I guess we're done. We'll do OSI another day. So so when you get in, what is the first few characters of the MAC address called? That's the like the vendor identifier, Ty. So the first few characters of the MAC address, that's what's used to. I'm not sure. Let me see. But I think it's called the vendor identifier. Organizationally unique identifier, and then network interface controller specific. I don't know what. Yeah. So it's an organizationally unique identifier. So that's the official name, but basically what happens is that portion of it, the organizationally unique identifier, is vendor specific. So every Cisco device has the same organizationally unique identifier. All Samsungs have the same thing. All Sony devices, all Microsoft devices, all those devices, or all those network interface, I should say, because not just whatever. All of those devices that have that NIC or that interface have the same identifier. And then the second part of the MAC address is device specific, right? So let's say if you have a Samsung, let's say you have a Samsung Galaxy 27, right? I know it's not out yet or whatever. But let's say you have a Galaxy Samsung 27. I have a Galaxy Note, whatever. When they look up the MAC address, whatever that identifier is will be the same. But then you'll have the unique identifier that says, okay, but this is a Galaxy phone and this is a Note. All right. So when dealing with IP addresses, you can do dynamic or you can do static, right? The difference between dynamic and static, let's start with static first. So remember how we were just talking about you're given an IP address of 192.168.1.10, right? Let's say for whatever reason you want that to be that IP address for that specific device at all times. You can assign it a static IP address so that anytime it connects to that internet connection, anytime it connects to your private internet connection, it will be given that IP address, right? So if so for some reason you want your computer at home to be 192.168.1.10, you go into your computer settings and your network settings and you assign it 192.168.1.10, right? For example, I have servers that have static IP addresses. Why? So that if I need to access it, I know exactly where it is at all times. Also, also it might, whatever programs or applications that are running on it might require you to have that static IP address. So you want to make sure that you have that IP address at all times because it is connected and therefore that's the only way it'll work. Then you have dynamic IP addresses, and dynamic IP addresses can connect to whatever available IP address is there, right? So one time you connect to it, it'll say, oh, this is IP address 192.168.1.11. The next time you connect to it is 192.168.1.15. The next time you connect to it, 192.168.1.7. It's going to find whatever is available and it's going to assign it, right? So it's dynamic. It's always changing. So IP addresses can be assigned manually by entering them, like we said, statically or automatically. And how is given automatically is used by a protocol known as the Dynamic Host Configuration Protocol, or DHCP. So the DHCP server, what the DHCP server does is when a device connects to it, if it hasn't been given that manual IP address, or like I said, if you didn't give it direct instructions to say this is what you have to give it at all times, then it'll say, okay, it's going to send out a request to say, hey, what IP addresses are available on the network. The HCP comes back and says, hey, you could use 192.168.1.7. Then the device is going to come back and say, hey, do you want to use 192.168.1.7? The device says, yeah, sure, give me 7. I'm cool with that. Then it comes back and says, all right, we acknowledge that you gave out 192.168.1.7. The device is cool with using 192.168.1.7. Therefore, the device now is using 192.168.1.7. That's the acknowledgement, right? For my boxing fans, think of when Muhammad Ali changed his name to Muhammad Ali, and everybody was like, "Your Cassius Clay." And he said, "No, my name is Muhammad Ali." Right? So Muhammad Ali is the name he assigned himself. That was a static name. It cannot be changed. It cannot go anywhere else. That's his name, right? And anybody who tried to call him anything outside of Muhammad Ali, it didn't connect. Or if it did connect, it was connected with, nope, that's not my name. And you saw what happened. If you're a boxing fanatic, like I am, or old school boxing fanatic, when was that Leon Spinks? So all right. So, and again, here's just a quick diagram. So the DHCP discover, hey, I'm new here. Is there anyone here who can give me an IP address? The DHCP server offers 192.168.1.10. Then it comes back and says, yeah, sure, that'd be great. I'll start using 192.168.1.10. And then the DHCP server says, great, you have 192.168.1.10. You can use that IP address for the next 24 hours. All right. And with that, we are going to go ahead and call it a day. Going to stop that. I'm going to go ahead and get ready to close up shop here. We got some stuff going on in a little bit. So I'm going to shut down the stream. Like I said, I wanted to get to Minecraft, but maybe I'll do it tomorrow. I'll do it tomorrow evening. I don't know. I think I have some kids coming from 5 to 7. So we'll see. If I don't do it tomorrow, I don't know. Maybe we'll do it Thursday. Sonny Liston. Thank you. It wasn't Leon Spinks. It was Sonny Liston. Wait, no, Sonny Liston. No, wait, Sonny Liston wasn't the. No, hold on. Wow, we're both wrong. Ernie Terrell. Ernie Terrell refused to call Muhammad Ali by his chosen name before their 1967 boxing match. Terrell instead referred to Ali as Cassius Clay. This fight is sometimes called the What's My Name fight. Wow. No, so yeah, I was about to say Sonny Liston. I think was his fight, and then after that, that's when he decided he wanted to be called Muhammad Ali after that, and then joined in the nation and all of that. Okay, and then he fought Sonny Liston for the rematch, and then he beat Sonny Liston again. Yes, something like that. All right, whatever. We'll figure it all out though. But yeah, I'm gonna go ahead and I'm gonna log off. Hey, Thumbstick, appreciate it. Groundbreaker, appreciate it. Ty, as always, appreciate it. Let's see. C Smith, what's going on, man? Thanks for joining the stream. If it's your first time joining the stream, please go ahead, like, subscribe, follow wherever it is you're watching. If you're watching it on YouTube, go ahead. We are streaming on 2 channels on YouTube: Alpha Cybersecurity and Alpha Esports and Technology. Same thing on Twitch. Actually, Twitch is my DJax page, and then Alpha Esports and Technology, or Alpha Esports Tech. And then LinkedIn, you can just go to my personal Davin Jackson page. So yeah, we're gonna keep this going. Like I said, we got we've entered the rabbit hole, so we're making progress. Now we're gonna jump in. So now we have a quick understanding of networks. We're gonna go from there. We're gonna cover a couple other topics. Probably go into the OSI model a little bit because I think that's going to be important. And then we'll cover the basics of Linux. And then from there, we'll go into the basics of penetration testing. We won't stay on we won't stay on pen testing too long because we'll then jump into web fundamentals. From web fundamentals, we'll jump into web app pen testing, and then we'll definitely get into the thick of it. During that time, we'll also be doing some other stuff. It's like setting up Kali Linux from a virtual machine or from a cloud setup. We'll probably do both, so you understand both. Figure out whatever your preference is. We'll also set up our vulnerable environment. So when we get to the hacking, get to the fun stuff, when we want to do a couple things that are a little bit more challenging, I'm still going back and forth on how I want to structure it. I want to make all of this as free or as easily accessible as possible. That being said, there probably will be certain things that will require you to follow the page. So it's not necessarily, transactional as far as financial, but transactional as far as following the page, or, maybe there's a landing page or something like that. I don't know. We'll see. But we're gonna explore all options because again, the idea is to kind of make those connections and get that content out there for people who are willing to learn. So with that, I'm gonna get up out of here because it's about I got 5 minutes before my next thing, and then I gotta head home. So hope y'all have a great rest of your night. I hope your week is a great week. I hope everything that you want with that is within your reach. Happens for you, obviously, as long as it's legal or healthy. Actually, and if it's not, it's none of my business. But I hope I do. I wish everybody blessings and have a great week. All right. Tomorrow, actually, I oh crap! I just thought of something. Tomorrow, I won't be streaming tomorrow because I got a bunch of kids coming here, and then I'm going to Gwinnett Tech. Hey, Thumbstick, um, are you going to the GGDA thing at Gwinnett Tech? If there's a game developer thing at GGDA at Gwinnett Tech. So I'm a pull up since it's right in my neck of the woods and I'm on the advisory board. So I guess I should probably stop by and say hi. So yeah, y'all go ahead and be safe. I'm gonna go ahead and get things going now. I got 3 minutes before my next event. So I'll holler at y'all later.